Hey everyone, welcome back to craftofprogramming.com. I am Nilton Santos, an electronic trading Java developer based in New York City. Today I'm continuing the exciting series on how to build a simple Java API using AI tools. So in this video I'm going to be using the just released ChatGPT 4.0 with Canvas, this tool. So today is October 5th, 2024, and this tool just got released in early beta version a couple of days ago. So I am a ChatGPT Plus user, and this tool is not yet available for the free users. But as per the OpenAI website, this tool will be made available for free, I think, for the free users as well. But not yet. This is early beta only for ChatGPT Plus users. So previously I built a simple restaurant reservation system in Java using the GitHub Copilot AI assistant. So if you missed that one and you're interested, please check it out in the description below. So the purpose of this series of videos is to make an objective comparison between the AI assistant tools. So I'm going to be comparing GitHub Copilot AI Assistant with ChatGPT 4.0, with Canvas, with Intellij AI Assistant, Tab9 AI Assistant, Claude AI Assistant. So make sure you stick around for the entire series. Hit that notification bell, subscribe, and leave a comment. Let's get started. So I basically want to play with a simple application like a restaurant reservation system. Very simple. It's not going to have a persistence like with a database. It's not going to have a user interface, something very simple. And it's your standard restaurant reservation system that has a very simple API here to add a reservation, to modify it, and to cancel it. And the reservation has a unique ID, has a reference to a unique restaurant ID here. So restaurant ID equals this ID here on the restaurant object. It has a name, your phone number, the party, the number of people in the reservation, the date, and the time. Okay, so that's the reservation. That is the object that is created by add reservation. You can obviously modify it. Say you want to change the party or the date or the time. You can remove the reservation. And basically, you can use a reservations object that's going to keep some kind of list organized by date. This is actually a map. And then you have a restaurant manager which manages restaurants, right? Adds, removes, and modifies restaurants, right? So now that you know the overview of the simple restaurant reservation system we're going to be building in Java, so let's get started. So you come here to the model and you change to ChatGPT 4.0 with Canvas. And then let's just tell it to launch the Canvas with a Java editor. Okay, cool. We have here Java editor. So let's start with a simple, let's start with a hello world Java app. Cool, now we have something here. Okay, so basically you have just a quick overview here. So now that I told it to launch the Canvas with a Java editor, so I have here a completely editor. So this is like any kind of editor you would have in VS Code or IntelliJ IDEA or Eclipse. So this is what we're going to be using. So this is pretty interactive editor. As you see, because we are in coding mode, so this is a Java editor, we have here these options to do code review, convert it port to a different language, fix bugs, add logs, and add comments. So I'm going to show you a few of these options as we go along. But the key aspect of this canvas is really that now you have an editor and you can select stuff here and ask ChatGPT, and you will see how as we move along this stuff is very interactive. Okay, now that I have our simple app here, let me tell it to rename to restaurant reservation system. Change the output statement accordingly. Okay, cool. We have our restaurant reservation system. Let's get started. So let's introduce here just like we did on the GitHub Copilot Assistant, the restaurant manager interface, restaurant manager. And this restaurant manager interface, if you guys remember, has the following three APIs. So we have here the add restaurant, which takes the name of the restaurant, the address, the capacity, the number of seats, the open and the close times, as well as the closures. This could be holidays. We have another remove restaurant method that removes the restaurant given its unique ID. So add restaurant returns a string, and this string is the unique ID that's going to be utilized here. And modify restaurant is basically to change any of those fields that are part of the restaurant. So maybe you want to change the name or the capacity if the restaurant got expanded and so on. All right. So as you see, the stuff is a little bit not well formatted. So let's just ask it to format. So it's, as you see, it's going up and down and it adjusts the formatting. All right, now that we have our interface here, let's ask it to implement it with the exact same prompts that I used in the GitHub Copilot AI assistant. All right, so let's select it. And then I have here the constraints. So let's ask it to implement this interface following these constraints. Okay, constraint number 1. All the input parameters must be non-null and semantically validated. For example, the capacity parameter must be a positive number and the closures list must refer to dates in the future. Constraint number 2, the restaurant must be open for at least 8 hours and the close time must be strictly after open. Okay. Constraint 3, validation failures must generate a runtime exception with a detailed error message. Constraint number 4, the modified restaurant method can be implemented simply by removing and adding a new restaurant. Okay, so very specific prompt, and importantly, for an objective comparison, this is the exact same prompt I used in the GitHub Copilot. Let's go. All right, so now we have our public static class here, restaurant manager impl, that implements the restaurant manager, and let's see what this thing came up with. So we have an add restaurant method. It's validating the restaurant parameters, and it's returning restaurant added successfully. Okay, we have to correct that because this needs to be an ID, but I didn't tell it, so it's fine. Remove restaurant. Okay, there's a bit of pseudocode here. Modified restaurant, remove and add. Okay, this is what I told it to do. So let's see what we have here in validate restaurant parameters. So it is validating all the input parameters for nullity with a nice description here. So capacity, if it's negative, okay, capacity must be positive. If the close is not after the open, okay, that's fine. And the open until the close, 8 hours less than 8, okay, cool, this is good too. And for each of the closures, if they are in the past, then it throws an illegal argument exception. Okay, cool, so this is okay as first pass. So first of all, I want it to actually create a restaurant class. So let's come here and tell it enhance the implementation with an actual restaurant class. Okay. Also, I want the restaurant must return a unique ID. Okay, let's see what it comes up with. All right, so now it's creating add restaurant. Now it's generating a unique ID here, and it's creating a restaurant object. And notice that it also created a restaurant map. Okay, now this class has a restaurant map, which maps the unique ID to the actual restaurant. Interesting, it shows a concurrent hash map. Fair enough, could have been a hash map. And we have an ID generator here, which it uses to, let's see where it is actually. So let's remove restaurant. It's checking for the nullity, and then it's removing from the map. Nice validation here. So if you cannot find the ID, it's going to throw an exception. Modify restaurant is implemented in terms of remove and add. So let's look at the generate unique ID, which is, okay, fair enough, UID. Okay, and the restaurant class is just simply like a POJO. Okay, cool. So there is one thing that I'm a bit confused, which is what is this ID generator being used? Because it looks like generate unique ID is being, yeah, it's using UUID. So let's ask it then. This seems like it's not used. Okay, where is this being used? Okay, not being used. Then come on, let's clean up this. Clean up. All right, so we're using the UID to generate unique restaurant ID, and as you see, it removed that ID generator, that random field from the restaurant manager. So interesting, the choice of concurrent hash map. I could have asked it to change it. That's fine for now. So let's look at validate restaurant parameters and see close time, restaurant must be open, closures. All right, so one thing I'm not too crazy about it is that it's not including the actual parameters on the error message, which I wanted to do it. So let's come here and say include the input parameters in all the relevant exception messages. Okay. Okay. Perfect. That's better. All right. See, now if something fails, what are the values that would actually passed? Okay. So it's using pluses. I could ask it to use string format, and I think for now it's good. Okay, I'm happy with this implementation of the restaurant manager interface. Okay. So we have the restaurant manager impl class, and we have the restaurant class here as well. So let's ask it to implement a is reservation date time valid. Today I can't type, sorry guys. All right. So this will take a local date time and an int duration in hours. Okay. So the whole point of this is so that when we are making a new reservation, we want to make sure that that reservation can be made against the restaurant, because the restaurant has closures, dates when it's closed, and obviously operation hours. So let's see what it can come up with here. So I did select the restaurant class. It still does this scanning, top-down scanning, but let's see. All right, so this is okie dokie. All right, so we are on the restaurant class, as you can see here, and it has implemented a method inside this class. So let's see what it did. So firstly, I like that it is doing the parameters validation. Okay. All right, if the closures contain our date time, then the date is not valid, it returns false. Otherwise, what it does is it gets the start time and the end time, and then it checks if the start is before the open and the end is before the close or equal to the close, then. Okay, so I'm happy with this. Let's keep going. So now what I want to do is I want to generate the reservation system interface. So let's collapse all of this stuff. All right, so everything is collapsed. And let's do the same thing here. So let me public interface reservation system. Okay, so the methods are, these are the methods here. So again, I'm being lazy. Let's just ask it to format the code. Okay, I wonder if I can just ask it to collapse. Okay, still generating. Is that why it's, okay, it's still generating. Cool. Let's see, collapse. Collapse all. Guess you didn't understand that. That's okay. All right, let's collapse it. Not reservation system. Let's collapse this. Okay. All right, same thing we did for the restaurant manager. Let's ask it to implement the restaurant reservation system with the following constraints. All right, so implement this interface following these constraints. Constraints, man, today I'm not typing well. Sorry, guys. So this is a lot of stuff here. Okay, constraint number 1. A reservation has a duration of 2 hours, okay? Constraint number 2, a reservation cannot be made on a date when the restaurant is closed, okay? This is why I added that method, is reservation date time valid in the restaurant. So I hope ChatGPT will use that method to make that, to follow that constraint. Let's see. Constraint number 3, a reservation can only be made between the open and close times of the restaurant, obviously. All right, constraint number 4, a reservation cannot be made if these new reservations number of people, so the current reservation that we're trying to make has a party as number of people. If the number of people in this reservation that we're trying to make plus all the existing overlapping reservations number of people exceeds the restaurant capacity against which we're trying to book that reservation. And the overlapping of a reservation is if they intersect each other in the restaurant's open timeline. This is a mouthful. Let me show you graphically. So this is the sort of a diagram of the reservations on the timeline. So this timeline here is the open and the close time of the restaurant. So this is the operating hours of the restaurant. and each of these intervals or brackets are reservations. So notice that all of them have the same length because again we're using a simplification where all reservations have the same duration, 2 hours. So this reservation is invalid. IR stands for invalid reservation because the start time is before the open. Likewise, this is also invalid because the end time is after the close. R3, 4, and 5 are existing reservations, and NR stands for new reservation. This is a new reservation that we are trying to book. What I'm just highlighting here is what I mean by overlapping. It's pretty clear what overlapping means, but NR overlaps with R5, with R4, and R3. So now that you understand this, let's keep going. Constraint number 5, all the input parameters must be non-null and semantically validated. For example, the phone number parameter must be a valid US phone number, and the restaurant ID parameter must refer to an existing restaurant with that ID. And 6, validation failures must generate a runtime exception with a detailed error message containing the input parameter that failed the validation. I believe we are on 7, right? The modified reservation method can be implemented simply by canceling and adding a new reservation. So again, this is the exact same prompts I used on the GitHub Copilot chat tool. Let's go. All right, so let's see what we got here. So we have the restaurant reservation system implementation, and we have a reference to the restaurant manager, which is being nicely injected here. You could have used an interface. We can refactor it later. And we have a mapping here between a reservation. I think it's a restaurant ID and a reservation object. Again, it's using concurrent map instead of a simple map. And this is to validate a US phone number. So let's see what it came up with. Add reservation. So it's validating the reservation parameters. We will see that. And then, okay, restaurant manager dot restaurant map. Okay, so we can definitely improve on that. We get the restaurant. And then if it is null, then we throw an exception saying that we cannot find that restaurant. Otherwise, if it's not null, cool. These are like that. So notice it's using the isReservation datetime valid to validate that we can make that booking against this restaurant. And then it's validating the capacity, okay? So is capacity available? So if all of these validations pass, then it generates a new reservation ID, creates a reservation object. So notice that it also creates a reservation object. I like that. And it adds the reservation to the restaurant, and then it maps the reservation ID to the reservation and returns the reservation ID. All right. So modify, simply cancel, and add. That's what I told it to do. Cancel reservation. So it does a lookup on the reservation map, given the reservation ID. And if it's not null, what it's going to do is going to get the reservation, sorry, the restaurant, and remove this reservation from the restaurant. All right. So let's see, what did it do? It validate reservation parameters here. Okay. So it's validating all of the input parameters for nullity. And if it fails, we have a nice descriptive message, including the parameters. It's using a nice pattern matching here in Java to make sure that the phone number matches the US phone number pattern. If the number of people is 0 or negative, then of course it needs to be positive. Okay, cool. So I like that. It's looking good. Now let's see. We have to fix this. I'm not too crazy about this restaurant map here that he added on the restaurant manager. Actually, let's go there and check. So let's see. Okay. All right, so we have a restaurant map here. Yeah, okay, so it's, yeah, we can improve that by providing at least a getter. All right, so let's collapse this stuff because it's getting a bit messy. Okay, let's collapse that. Let's collapse the restaurant. So validate reservation parameter is just checking, doing semantic checks on these fields. What we really need to make sure is capacity available. Let's take a look at that because this is very important. So let's go to the collapse this. Let's go to the restaurant. Okay. So by the way, it generated a nice reservation object as well, right? Again, it's a simple POJO, but I think something important here is overlapping, right? So there is a method here in the reservation that contains the time of the other reservation, especially to check whether two reservations overlap, okay? So basically it's going to get these reservations, start time plus the duration. So this is when the reservation ends, and the other when the other ends. And then it's going to check if this date time, the start of this reservation, is before the other and the end of this reservation is after the other, then they overlap. Okay, notice that we could have just passed here just the reservation. Okay, for example, why not? Let's just ask it overload this with a method that takes a reservation. Okay, so as you can see, it created a nice overload here. Right. All right, so let's go to the restaurant class, because remember it added a method called isCapacity available that we need to check. Right, so let's see what it did. All right, so isCapacity available, what it is doing is this time is the time of the new reservation and the number of people. So the new reservation start time and the new reservation's number of people. Okay, so what we're counting here is we're counting the total number of people of all the reservations for this restaurant that overlap with this new one that we are making. Okay, and then we add this count to the number of people in the new reservation, and if this count is less than or equal to the restaurant capacity, then capacity is available, otherwise it's false. All right, so this code has the same bug that GitHub Copilot had. So if you want to see how to fix that, please refer to the GitHub Copilot AI assistant where I fixed this bug. I don't want to make this video too big. So I think to end, let's just ask it to generate tests. So let's come here and actually let's just, okay, add JUnit 5 tests. Okay, so the system just crashed. It's early beta, right? So we have to be flexible with it. So let's try again. Add JUnit 5 tests. Right. All right, so we have a pretty good coverage of JUnit 5 tests here, and let's just ask it to add comments just to end the video. Add Java docs. Okay, so what's the verdict for this tool? It crashed a few times when I was using it. It's still in early beta. Also, it's pretty interactive, but I think this is more useful to build just very simple classes, because as you saw, as the number of classes and interfaces start growing, it's starting to get a bit hard to manage these on a single editor. But anyway, let me know in the comments what you think about this. Like I said, in the future videos for this series, I'm going to be talking about the Tab 9, Claude AI, Intellij AI Assistant. So anyway, if you found this video useful, then please don't forget to subscribe, hit that notification bell so that you get notified when I drop the next video. All right? I'm Nilton from craftofprogramming.com. Thanks for watching. Bye-bye.